Yes, we are live on.
Good morning, everyone. Regional Science Center Bhopal has brought one very important event on this very special occasion when most of the part on our planet is going to observe annular solar eclipse. However, it is not
Yes, we
visible
are
from
live on.
India, but we can enjoy the festivity of this eclipse. Good morning, everyone. Regional Science Center Bhopal has brought one very important event on this very special occasion. Swapnil, I am getting my own sound. On our planet is going to observe annular solar eclipse. However, it is not visible from India. We can Swapnil, you have to stop. Your echo is coming. Your mic is recording once again. स्वप्निल तुम वहां प्ले मत करो ये प्रोग्राम वहां पे प्ले मत करो इको इज कमिंग योर माइक इज सॉरी हम लोग कुछ टेक्निकल ग्लिच के लिए क्षमा चाहेंगे आप सबसे वी आर एक्सट्रीमली सॉरी फॉर technical glitch. This is the era of technology and we all are learning new normals in this COVID-19 pandemic. So somehow, sometime we may come up with some unexpected errors. So forgive us for that. But Science Center once again is back with you all. Today is a very special occasion, as I was mentioning earlier also, because northern part of the world is going to experience, especially North Canada, Greenland and Russia, most of the part from those countries are going to observe annular solar eclipse. And as we all are listening, reading and hearing about, this is the first solar eclipse of 2021. To enjoy this festivity of that solar eclipse, we have with us very important and great scientist who has been working in this area in solar physics. So before we start today's program, I would request my colleague, he is also heading the Science Center, Mr. Krishnendu Chaudhary, to say a few words about the center, then we will start the program. Krishnendu ji, over to you.
Thank you. First of all, very good morning to all the viewers of this channel. I express my sincere gratitude to Dr. Dipankar Banerjee, Director ARIES, on our digital platform, and also welcome all the viewers to this program. As my colleague already mentioned, today is a celestial event, annular solar eclipse, which is about to start somewhere around 2 p.m. And he's also said that we won't be able to watch this beautiful phenomenon. And somehow I think this has to be understood that eclipses does happen every year, and somewhere I think it can happen, goes to around 7 eclipses a year, which includes solar and lunar. But each part can't observe the eclipses, and this is something very interesting. And I'm sure with this talk also a lot of things will come up, a lot of stories will come up associated with the phenomenon of eclipse. For example, if you try looking back into the annals of history, you'll find many civilizations, they hold different myths and associated superstitions. Even in Indian custom, we used to have a lot of myths like Rahu and Ketu. These things are associated with our civilizations, mythological figures. So basically, the ancient people, they didn't have any scientific explanation. So some kind of spiritual explanation they used to provide this kind of disorder or disruption in the normal phenomenon. So this kind of things gradually came to be cleared, or the with the understanding of the science and phenomena that they have come up. And I think these eclipses also have given a lot of opportunity to discover various scientific principles, and I think all these things will be uh, covered or maybe touched upon in this lecture. And besides this, I will also like to talk about the Science Center, because Science Center is basically here to grow awareness about different scientific phenomenon. That is our prime role, and we do science communication in various mode, and that is what we are going to do here also today with the one of our educational program, and where we try to talk about different scientific phenomenon which is happening nearby. So I hereby stop my talk here, and I again express my sincere gratitude to Dr. Dipankar Banerjee, Director ARIES, for accepting our invitation, and to who has accepted to throw some light. And on this particular eclipse, though we won't be able to watch this phenomenon, but definitely we are going to gain a lot of experience from you, because we have, as I learned that we have been to different places of eclipses. So it's over to you. Thank you very much.
Thank you, Krishnendu ji, and also thank you for bringing such mythological references and earlier ancient practices when we were observing solar eclipses. Scientifically, हमेशा ये बहुत महत्वपूर्ण रहा है, और साथ ही साथ में कल्चरल चेंजेस के साथ इसका हमारी समाज पर भी कहीं ना कहीं सीखने में, समझने में, या जो भी लोगों की भ्रांतियां रही हैं वो विज्ञान ने समय के साथ दूर की हैं। और ये जो सेलेस्टियल ड्रामा होता है जिसे हम सब बड़े खुशी से वेट करते हैं निहारने के लिए, भले वो भारत से अवेलेबल नहीं है, पर हमारे साथ जो आज एक्सपर्ट हैं डॉक्टर दीपांकर बैनर्जी, वो वर्तमान में आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज एरीज जिसे हम सब कहते हैं, नैनीताल में स्थित है, उसके निदेशक हैं, डायरेक्टर हैं। और सबसे खास बात, आज वो इस पूरे व्याख्यान में उनका व्यक्तिगत एक्सपीरियंस, बिकॉज लगभग 4 से 5 सोलर इक्लिप्सेस एक्सपीडिशंस में उन्होंने काम किया है, अदर देन हिज डेडली serious research in space weather and solar physics. So we requested him, and he agreed to share his experience in the event, in this discussion as well. He is going to talk about the solar physics of our country's current contribution and upcoming facilities. So Dr. Banerjee's area of interest is the sun and the solar atmosphere. His work involves theoretical and numerical modeling using data from ground and space-based telescope. As we all know, for studying outer space or celestial objects, we need to study from ground-based telescope, which starts from very small 3-inch, 4-inch amateur kind of aperture till 10 meter and upcoming 30 meter and 42 meter, if budget permits, European Union also. So bigger telescopes are coming, but for the solar physics, sir will talk about India's upcoming facility as well. And his work has enriched our understanding deeply about our own star, parent star. We talk about other stars in our galaxy, but the very important star which is making us alive on our planet, the sun, and its impact on our space weather. This is one area where the whole world is seriously looking now, space weather, because we are putting many number of satellites in the orbits, and space weather sometimes severely affect our satellites' health as well. He is the co-chair of the science working group of Aditya L1 mission, which is upcoming India's first solar observatory in the space, which is going to be launched by ISRO if everything permits according to the situation of COVID pandemic and budget constraints. So hopefully by next year it will be launched. And he is also the project coordinator for the National Large Solar Telescope project, which is upcoming mega facility of India's own solar telescope. He is also involved with NASA's Punch mission. So we'll talk about why this Punch mission is very relevant with space weather. And very briefly about his background in education, he is an astrophysicist with a bachelor's degree in physics from St. Xavier College and a master's degree in theoretical physics from University of Kolkata. He has obtained his PhD from Indian Institute of Astrophysics and completed 2 postdoctoral tenures in reputed institutions in Europe. And afterwards, when he was doing a PhD at IAEA, and afterwards he also joined IAEA for a longer period. And now sir is heading ARIES. Sir, over to you.
Thank you very much, Saket, for your kind introduction, and also, providing me this opportunity to come closer to, particularly to the younger colleagues. Yeah, these are difficult times and slightly odd, probably, in terms of, the situations. Ideally, we prefer to meet people, face to face, but whatever we could manage to do now, let's try this. So let me try to hide this screen again. Just to confirm, you are able to see my screen well and also hear me well, right?
Yeah, we can hear you and we are seeing your presentation as well.
Okay. So thank you again for giving me this forum to the Regional Science Center, Bhopal. Hopefully, I'll be able to visit in person your science center and meet all of you in person as well. So, as Krishnendu pointed out, I will try to give a flavor of different elements, about solar physics. Just why do we study sun? Then why eclipses are still important scientifically, and also as a human being, we shouldn't be afraid of eclipses. These are natural celestial phenomena. We should enjoy the eclipses when such opportunities come, but again with with the care and caution, because we shouldn't directly look at the sun. And the future facilities and all that, maybe I will very briefly just mention about it, and maybe we can take it up during the questionnaire session. So here I am. This is a beautiful, Manora Peak near Nainital, and I'm sitting right in this hilltop, and we have some old telescope at this campus, and I will talk about it. The other, telescopes which we have in our new campus in Devastal. So as you see, the weather is very similar to what you see in this movie right now. The monsoon has, come. But we are above the clouds sometimes, and this is the boundary layer, what you see as well. So it's a beautiful place to be, do research, and enjoy, the nature as well. So this is where the Manora Peak, and this is the lower panel shows our new campus at Devastal, which is 50 kilometers east of Nainital city, and we are about 10 kilometers away. A close-up view of the place where I am, and I'm actually sitting right here in this. If you peep in, or if you have a drone camera, you can see me from this window here. We have, all the residential, facilities, the student hostel, auditorium, everything in this campus. So we are almost, living in a bubble, bio bubble now at this point of time. This is our new campus, and as you see, this is the nation's pride of 3.6 meter Devastal optical telescope, which is the largest of its kind from this part of the globe. We have a 1.3 meter Devastal optical telescope, which is operational from 2010 onwards. This is a slightly smaller telescope, and we are also going to have a 4 meter class liquid mirror telescope. This is in collaborations with the Belgians and the Canadians. We were supposed to have the first flight last year, but because of the pandemic, our collaborators couldn't travel from abroad, and we are hoping that this winter, this is all scheduled now, and probably somebody will inaugurate this from the government side as well. So this is, I think, the nation's pride now, this campus. So that's a 3.6 meter Devastal optical telescope. This is a close-up view of this 1.3 meter telescope, and you see the beautiful Himalayas in the background. And as I mentioned, it's really a pleasure to really work here in this kind of environment. This telescope is looking at primarily to the optical transients and variables like supernovae, gamma ray burst, and AGNs, and so on. Today, I'm not going to talk about any of these elements, but if you are interested, you can come and visit us. This is a close-up view of this 4 meter liquid mirror telescope. Of course, this will be the largest telescope of its kind again, but a liquid, rather than a mirror, it's a mercury which is used in a ball. So it's a very indigenous, kind of concept to use a mercury ball as a reflecting surface rather than a glass, surface. It has its own limitation in terms of the maneuveration and so on. But you can imagine if you have such a large, light collecting area, you can look at a very, very distant object. So it will be, dedicated for looking at distant quasars and supernovae and so on. So this is a close-up view of our 3.6 meter telescope. Again, since this is the largest telescope in the country, it is also dedicated for faint galactic and extragalactic sources. So as I said, I will not talk about those, but I will just introduce our nearest star, the sun. The sun provides all our energy, and if if we can cut through the interior of the sun, then if you go all the way to the center of the sun, there is a core where these nuclear reactions are taking place, which generates the energy through a pp chain reaction, and it generates neutrinos and other energies and all that. But of course, the photons which are generated, it takes a very, very long period of time to come out of the sun, because it undergoes a lot of collisions and then it gets re-excited and so on. So this the core is where these thermonuclear reactions are taking place. Then we have a layer called radiative zone, where energy is transported primarily by radiation. See, for the high school children, you know that energy can be propagated by different ways. So one process is radiation, then the convections and so on. And exactly that's what happens inside the sun also, that the last 30% interior, the energy is transported by convection, just like boiling a soup, where heat is transported to the photosphere. So the visible surface, when you look at the sky, the surface, what you see is the visible surface of the sun, because we can see it in the optical wavelength, and that is what is named as photosphere. But then the other different layers of the atmosphere comes in. The temperature of the photosphere is about 6,000 Kelvin, and as we go away from the surface of the sun, then the temperature initially drops a few 1,000 degrees or so, but then temperature starts increasing again. This is actually not expected from a normal celestial body, or even say a planet like Earth. As we go to the mountains, you know that the density drops off and the temperature also drops. So normal thermodynamic processes cannot explain these subsequent increase of the temperature. So as we go away from the atmosphere, say all the way up to 2,000 kilometers, so this is a layer called chromosphere. These layers are called chromosphere. And then temperature seems to be suddenly jumps from tens of thousands of Kelvin to millions of Kelvin. So this is plotted in the log scale. So as you see here, 10 to the power 6 here, is the temperature of the corona here. And these layers, which is the extended part of the solar outer atmosphere, is called the corona. In fact, this is the good corona in my mind. To be honest, the name of the virus corona has also come from images of the corona taken during total solar eclipses. So this is a irony that the structure of the solar corona with these filamentary natures and bubbles and so on were observed hundreds of years back during the total solar eclipses. And the biologists, when they looked at these viruses through the microscope, they felt the similarity, and they named this as the coronavirus. So that's also a fact, actually. So the question is how this corona is so hot, because as I indicated already, that normal thermodynamic process cannot explain the high temperature of the corona. Again, the same plot is shown here, right inside the sun at the core, because of the thermonuclear reactions that needs a very high temperature, high density, and so on. There the temperature is tens of millions of Kelvin. But then as you come to the surface, your temperature drops. That is what is expected, because you are going away and away from the source, and the surface temperature is only about 6,000 Kelvin. But then when we go away from the surface again, temperature jumps very, very dramatically, and it remains at this high temperature for very, very large distance. So this is very difficult to explain through normal thermodynamic processes. So now we know that there are not a lot of non-thermal processes which are responsible for the explanation of these high temperature, and that is a field where some of us work more deeply. I won't be able to give you all the technical details, but basically what drives is the magnetic field in the sun. What we am showing here is again a solar image taken from the satellite, and this is a NASA satellite called Solar Dynamic Observatory, and the background image is taken in an extreme ultraviolet image, which is representative of 0.8 million degree Kelvin plasma as well. And as you also can imagine, when any substance is at such a high temperature, that becomes into a plasma state. It doesn't stay in any gaseous state anymore. So what is a plasma? plasma is nothing but a combination of charged particles and neutrals and so on. So when you increase the temperature, things go under phase transition. So from liquid you get to gas, and from gas you can get into this plasma state. So outer atmosphere of the sun is completely in the plasma state. And now we understand that in the sun, there are regions where there are, very bright emissions coming. So even if I take this EUV emission, we clearly see in the sun, there are certain regions where there are emissions are much brighter as compared to other regions which are comparatively cooler. These regions are called active regions. And now we know that these active regions are due to the presence of a strong magnetic field. And whenever there is a magnetic field, as you know, magnetic field always comes in a bipolar, like a dipole or magnet experiment, what you do in the laboratory. It's with the North Pole, and then the lines of force is connected to the South Pole. So here, that is what is indicated here, that these active regions, which are magnetic in nature, are connected by magnetic field lines, and the plasma is confined through these magnetic field lines. There is a property of these plasma that this plasma is called frozen in. It is not allowed to move out of these magnetic field so easily. So if there is such a strong magnetic field present in the sun, these underneath in the photosphere, if I look in the white light, I will see dark regions. They're called sunspots. So these sunspots are a composition of these active regions, and they're connected by this magnetic field topology here. The interesting thing is that this, these active regions are connected by closed magnetic field lines, whereas there are other regions in the sun. Suppose I go to the polar region here, you see it appears it's slightly darker, probably it is less dense, and also the magnetic field lines are more open. So that provides you a natural channel to escape from the sun as well. If your particles are there, as I indicated here, that in the active region, things are closed, so the material is not able to escape, but whereas in the polar region, things are going to escape more easily. These complex active regions, they undergo also a lot of dynamical changes. Suppose, these magnetic structures, we call them magnetic loops, they are twisted and, are shaken at the foot point and so on. They often erupt. And when they erupt, they basically eject all the material which is confined within these magnetic structures, and that leads to the coronal mass ejection. A large amount of mass is ejected in the corona, and those mass can travel through the interplanetary medium and eventually hit us as well, and it interacts with Earth's magnetic field and all that. So I will not be able to give you all that details. Maybe you can watch some other of my lectures which are available in YouTube, or maybe some other occasion we will be talking more about this coronal mass ejections and its impact on the Earth and the space environment in general. What I thought today, I will again talk about a little bit about the corona and the coronal magnetic structures, because this is in the context of the eclipses, because it is the eclipse only gives us an opportunity to block the solar disk completely and see the corona from the ground. Artificially, we create eclipses from the space. So until the space era, the solar corona was not possible to be observed from the ground regularly. There were some device called coronagraph, which artificially blocks this solar disk and looks at the extended part of the atmosphere or the solar corona. From the ground also there were some efforts, but the total solar eclipses provided historically, more than 100 years, scientific experiments to be conducted. And I will again give you some glimpses. Again, it will not be comprehensive because there were many experiments which were done. I will only give you, few examples here. And then again, there are many such talks in the public media, or you can contact me. I can explain the other scientific experiments which were taken. Here, what I'm showing is this is the kind of the magnetic structures in the corona. What is expected from our understanding of the theoretical understanding of the coronal plasma, in general. There is observationally a big challenge of measuring this coronal magnetic field. So this has been a very difficult problem, and we have not been able to do it comprehensively. There are observations of magnetic field on the surface of the sun, because the magnetic field also very strong of kilogauss strength, and through a process called Zeeman effect, which basically splits the spectral lines, and that from the measurement of the splitting, we can get an estimate about the magnetic field. This is again for the high school physics. Probably you have heard about Zeeman effect, which gives us a measure of the magnetic field. There is also some experiment called solar polarization experiment. Spectropolarimetry also allows you to get an estimate about the magnetic field on the lower surface or the low chromosphere of the sun. But to do that in the corona is very, very challenging. We are planning to do that experiment from the Aditya L1 mission, and in some other occasion one can discuss about it at a larger depth. But here, what I'm showing is that this is a work from one of my colleagues from ARIES, Kolkata. There is a center called CESI, and I'm also a faculty at CESI. So there's some modeling happening in terms of the global field, how it should look during the eclipses and so on and so forth. So there was a prediction which Professor Nandi and his students did before the eclipses, and then later on after the eclipse was seen, they were compared. I will show you some examples which is happening in the US as well. So this is again the prediction. I'm flopping so this is prediction, this is a real observation. So you can compare the real observations with the predictions. Of course, you see there are a good amount of match, but there are still differences because of our lack in understanding of the details of this magnetic field evolution. So I just wanted to give you a flavor that these are very highly sophisticated, computational, results. This is from Predictive Science Center in US, and a similar kind of experiments are being done in India as well, and we are doing reasonably well. So here, this was the total solar eclipse of 2017. This is an experiment which corresponds to the great American eclipse of July 19 as well. I take you back a little bit of history. As I mentioned, I will just give you a little glimpses. And Krishnendu mentioned about eclipses and mythology. It is not the eclipse; it is darkness that frightened our ancestors. Because they were not aware why suddenly the sun is becoming so dark. So, which you can't explain. You always get into in a frightening mode, and then superstitions kicks in. So sunlight that nurtures life, positive attributes of the sun would be shut out during eclipses. Something bad that is about to happen. So in India or China, most common meets, sun and moon are being consumed by Rahu or Ketu, which is again been mentioned by Krishnendu. Sun is eaten up by animals is very common in different cultures. So they make sound or burn fire to scare off the animals. So these were all things happened thousands of years back. Here I will actually give you a animation, because as I mentioned, there are many sources available in terms of explaining the eclipses, and beautiful animations are made by National Geographic, NASA, and other resources also. So I thought I will, what is already available, share with you to explain the different type of eclipses. So it's a few minutes, animation. So you can go through it, and we will take up questions later on. So this is made by National Geographic, and
moves between the Earth and the Sun, blocking some or all of the Sun's rays from reaching the Earth. By cosmic chance, even though the Sun is 400 times wider than the Moon, it's also 400 times farther away. Therefore, the two objects appear the same size in our sky. Astronomers are able to predict eclipses because the Earth and Moon have very predictable orbits. Why then isn't there an eclipse every month? The Moon's orbit is usually tilted a few degrees north or south in relation to the Earth. When the Moon does eclipse the Sun, it casts two types of shadows on Earth: a smaller, darker shadow known as the umbra, and a larger shadow known as the penumbra. There are four types of solar eclipses. The first and most spectacular is a total eclipse, when the Moon completely covers the Sun's surface. A total eclipse can only be seen if you're standing within the umbral shadow. That's why the imaginary line created by this shadow as it races across Earth is known as the path of totality. People within the penumbral shadow see only a partial eclipse, the second type. From this view, outside the path of totality, the moon passes in front of the sun off-center, never fully covering its surface. Third, an annular eclipse occurs when the moon passes directly in front of the sun. However, unlike a total eclipse, the moon appears too small to fully cover the sun. The moon's orbit is elliptical, so sometimes it's closer to Earth and sometimes it's farther away. Last, a hybrid eclipse is when the moon's position between the Earth and sun is so finely balanced that the curvature of the Earth plays a role. The moon will be farther away from some parts of Earth along the eclipse's path, resulting in an annular eclipse. In other parts, the moon will be just close enough to fully cover the sun, resulting in a total eclipse. While a total solar eclipse happens somewhere on Earth every year or two, any given point on Earth experiences the event only about once every 400 years. We interrupt this video for an important safety announcement. Looking directly at the sun, even during an eclipse, can cause permanent eye damage. Fortunately, there are ways to enjoy an eclipse safely. The easiest is to use certified eclipse-watching glasses, which are shaded thousands of times darker than typical sunglasses. You can also look at the eclipse indirectly by making a pinhole viewer. Simply poke a small hole in a piece of cardboard. Hold the cardboard up to the sun, allowing the sun's image to be projected onto a flat surface. Be sure to look only at the surface and not through the cardboard. Just before the moon completely covers the sun, low-lying valleys on the moon's edge will be the only spots that sunlight continues to pass through. These remaining brilliant shafts of light, known as Bailey's beads, will disappear one after another. And finally, a single bead of light remains, known as the diamond ring, signaling that you're just seconds away from experiencing totality. Once the last bead disappears and the moon completely covers the sun's surface, the totality achieved. At this point, none of the sun's rays are reaching your eyes, and it's the only time that it's safe to take off your glasses. Remember to put your eclipse glasses back on before any of the sun's rays start to peek through again. Any sunlight reaching your eyes, even for a few seconds, can cause serious damage. While an eclipse can last a few hours, totality typically occurs for less than 3 minutes. Animals and plants have also been known to alter their behavior during a total eclipse. Songbirds may stop singing, crickets may start chirping, and flowers may even start to close up. We won't always be able to see total solar eclipses. The moon moves about 1.5 inches away from Earth each year. It's estimated that in about 1 billion years, the moon will be too far away from Earth to completely cover the sun.
So I think that's a beautiful, short animation made by National Geographic with help of NASA that explains, all the, different eclipses and so on. So these are also essentially slides, which is this resource is called the timeanddate.com. This is a very nice website which explains, different celestial, events, particularly eclipses in a very, very nice explained way. So the solar eclipses do take place in the new moon, must be at or very close to one of the lunar nodes. So these are called the lunar nodes. And also it is explained that there is a 5-degree angle, and that is responsible that why you don't see eclipses in every new moon also. So if the moon is not near lunar node, the sun, moon, and earth do not align in a straight, and a solar eclipse cannot take place. So even if is 3 are there blocking each other, but they will not block completely because of these 5-degree angle between the orbits. very few historical facts. So in 1605, Kepler gave a scientific description of a total solar eclipse. And then Halley, who is a famous Halley's Comet named after him, predicted the timing and path of the total solar eclipse on May 3, 1715. So imagine way back, so many hundred years back, they could already start predicting the timing of the eclipses. So that is only possible when you have these orbit information very accurately known. Also, the sizes of these objects are very accurately known. So his calculation were only 4 minutes, about 30 kilometers off from the actual timing and path of the eclipse. So I think we really have to salute this, these scientists. What kind of perseverance they had to achieve this. So as it is explained that these are the sizes of the sun also appears slightly different because of the different locations in these orbits. These are called aphelion and perihelion, and apogee and perigee is the conditions in the context of the moon. It refers to here. There is again this diagram. What is showing here that when do you expect to see a total solar eclipse? When the moon is completely blocking. And also, you have to be in the region of A. So when you have, on Earth, certain region where the complete umbra is casted, then you will see total solar eclipse. And if you are in these regions, you will only see a partial eclipse. And then at the point C, if you are here, then you see annular solar eclipse. That means the moon is not able to completely block the solar disk. But it creates a rim because the moon appears slightly smaller in size as compared to the size of the sun. Of course, these distances are not in scale as well. So that's an important thing to remember. I was told to share some of my experiences of eclipses. So this is a eclipse which we went with a full expedition in China in 2009. This total solar eclipse was visible from India also very well. There are two more eclipses which I participated. I will just tell a little story about it. Way back in 1995, there was a total solar eclipse, again visible from India, almost very widely viewed. I was fortunately selected by the military, and I was flying through a Russian aircraft. These are called transport aircraft AN-32. So we flew out of Agra, and then I was with the military crew and some of I was a PhD student at that point of time, and when we were at around 12,000 feet height, we opened our hatch and we took our camera and was taking pictures. So that's again lifetime experience. I can't believe it. Of course, we had rehearsed this thing with the military guys for 1 week before the eclipse days. What would be the path of the shadow, the way it goes. The idea is when you are in an aircraft, and if you can really travel very fast, then you can gain this totality duration also. Of course, we were civilians, so we were not allowed to go to the MiG. There was a MiG also which were flown, and there, of course, MiG cannot afford to, open up the hatch and take pictures. So there were automated, cameras and all that fitted in the MiG, which gained, a few minutes of totality as well. So this was a fantastic experience way back in '95. Then I was in Europe, and that time there was a eclipse in 1999 also, and I was invited by a cruise liner from Ireland, and I was a sort of expert because the totality path was going through the sea. So it was important to go to a water body rather than the land. So I was in that Irish cruise liner and enjoyed the eclipse. It was a little cloudy, but within the clouds, some totality was visible and so on. One of the best eclipse experiences, of course, is the China one, because we took a lot of instruments. So you can see there were the two 40-centimeter telescopes. And then we had a tent with a spectrograph with observations of spectral lines and so on. So this was the image of the corona which we took. You please note that these are scientific experiments. It's not always so pretty as the amateurs will produce, but there are very specific filter we use to characterize the temperature of the corona. Amateur, white light image, you will not be able to do those kind of sciences. And we also had a spectrograph, which has the spectral, slit situated somewhere here. So we were, characterizing the plasma properties, its velocities, densities. So these are real scientific experiments, which you can say. I looked much younger at that point of time. So these are some of the spectra which we collected. I was behind this spectrograph in the tent. So what I was doing is I started the sequence, because you have to estimate what exposure time you want to give and so on. And then I rushed out to see the total solar eclipse with my open eyes, because you can't miss that opportunity as well. So we took images in two iron ionized line filter. These are called red line and green line. In fact, these experiments during the total eclipses has given us a lot of to do experiment from space. So the Aditya L1 mission, we have very specific experiments, which is based on some of the data or findings which we did from these eclipses as well. So that has a lot of advantages. Then next year, I was again very fortunate to travel to Chile, and this is a very isolated place called Easter Island. Not many people get even an opportunity to visit Easter Island. There are a lot of mythological stories about this, how the civilization came here several thousands of years back. There are these kind of monuments available in that island, and we pitched our tent there and observed that. So as you can see here, that this is primarily, this eclipse path was mostly through the water body. And there was a small little island, which is called the Easter Island, where we went. It's actually a 4-hour flying time from Chile in the plains. So it was a small little aircraft with all our equipments and all that. We traveled there. So this was July 11, 2010, more than 10 years back. This again, this small little island, a beautiful place, amazing, history. This is again, these statues, they date back, more than 6,000 years. So people still worry, how come there was a civilization in such a small little island when other places had no civilization. This again, our group picture. This was led by Professor Jagdev Singh, our senior faculty, and Professor Siraj Hassan, my thesis supervisor, and then the Indian ambassador from Chile, he also came, and some of my colleagues, Ravi and Gabriel, both were behind all this. So you can see that our experimental things, spectrograph was inside this tent, and we have all these cellular arrangement where you could direct the sunlight into this tent for observation. So it was a pretty good scientific thing. Again, I was fortunate to go to Argentina in July 2019. This movie is actually from the Chile side. So there is a border thing, between Argentina and Chile. There was a conference in Argentina. I attended the conference. This time we couldn't carry large, scientific instruments. It was not a form of a full-fledged expedition, but I was fortunate enough to see the eclipse from our small cameras, and it's a fantastic experience whenever such event happened, and that too when you are able to reach such remote locations, which itself is very, very difficult to reach. I just wanted to mention that last year itself, same 21st June also, this was during the pandemic. We couldn't do a big experiment in different parts of India, but we did observe some annularity even from Nainital. So from our own campus, there were clouds, but we did observe the annularity for a certain period of time. And so this is the current one, which is going to have in another couple of hours. As it was mentioned in the beginning by Saket, that unfortunately it is again going mostly through the water bodies. It starts with part of Canada, and then so the totality, you will see this red one identifies the totality path, and rather annularity path. This is not a total eclipse, it's annular eclipse. And then it goes through the Greenland, and then again a large water body or ice and then it will touch a bit of Russia, and that's it. So it is going to be visible in a couple of hours time from now. There are again timeanddate.com is a very good resource. They will have live telecast also. So you could, point I will probably point that out again. So time and date.com is also giving you these animations that when the moon is going to cover. This is, of course, a little bit fast forward. This is the full eclipse start. And then you see the annularity. And then again, the moon will pass by. And you will see the partial phases as well. So these are all there in the timeanddate.com. I will strongly encourage you to visit this website just after the talk probably, and then you can watch this. Again, a few more warning messages, which was there with that movie as well. Never look directly at the sun, whether it is a partial or a full. In fact, the partial phases are much more dangerous. The total eclipse during the totality, exactly during the totality, the emission which comes from the sun is 10 to the power minus 6 times the solar disk luminosity. So it is safe to observe it, but you should know when the totality is. So only during the totality you can look at the sun. Otherwise, you have to use different devices. So this is one easy way to do it. We can just make a pinhole, on a piece of paper or a cardboard, and you can actually take this pitch board a little back and forth. From the ground, say in the ground, you see the, place a white sheet of paper, and when you place this, pinhole, just to adjust the distance, you will see at certain place, you will see a very nice, solar disk image. And during the partial phases, you will be able to see this stuff. Of course, use solar glasses. Use welding glass of shade 14 or darker. This is again, sometimes one needs to be a little bit of careful, because sometimes there could be small little scratches and so on the welding glass. That is harmful. So if you have a very good source of welding glass, a very dark welding glass, then only you can use it for that. This is just a screenshot of last year, our experience from here. We were also doing a live telecast of this event. As you see it, we had clouds, but we had some glimpses of the annularity, and this was our team from the solar telescope. We have a 15-centimeter solar telescope. I didn't talk about it much here, but which is used for solar flare observations. So we did use some filters, and we could observe this annularity.
कि आप अपनी क्वेश्चंस के आंसर्स अगर हिंदी में भी देंगे तो हम उन लोगों के लिए भी पहुंच पाएंगे, ताकि भाषा किसी प्रकार का अवरोध ना हो साइंस के लिए।
Absolutely. मैं कोशिश करूंगा, बट मेरा हिंदी उतना खास नहीं है। आपको भी मालूम है,
जितना आप हिंदी बोलते हैं उससे बहुत काम चलेगा सर। थैंक यू।
ठीक है, मैं कोशिश जारी रखूंगा।
तो सर हमारे पास कुछ प्रश्न भी आए हैं, तो जिसमें से एक बड़ा इंटरेस्टिंग प्रश्न है, एक टीचर ने पूछा है यहाँ से, मैं वो भी आपसे लूंगा। उसके पहले मैं आप थोड़ा स्कूल्स के बच्चे हमारे साथ जुड़े हैं और कुछ कॉलेज के बच्चे भी देखेंगे इस प्रोग्राम को, कि आदित्य L1 जो मिशन है एक कोलैबोरेटिव मिशन है। ये इसका मूलभूत उद्देश्य क्या है? जब दुनिया में इतनी बड़ी सोलर ऑब्जर्वेटरीज अलग अलग कंट्रीज ने लॉन्च की है, नासा का खुद का आप अगर SOHO की बात करें, उसके बाद का फिर स्टीरियो मिशन की बात करें, या फिर उल्लाइस मिशन भी था बहुत पहले, और बाकी कंट्रीज ने भी बहुत एफर्ट्स किए हैं ग्राउंड बेस्ड एंड स्पेस बेस्ड। तो हम आदित्य L1 जो कि लैग्रेंजियन पॉइंट L आप बात कर रहे थे, वो तो उसकी लोकेशन हो गई हमारे स्पेस में, और वैज्ञानिक रूप से हम सूरज के बारे में क्या जानने का प्रयास करने वाले हैं आदित्य L1 से?
बहुत बढ़िया क्वेश्चन है। तो पहले ये बात है कि ये इंडिजिनसली इंडिया में हो रहा है। सो इट इज कंप्लीटली मेक इन इंडिया प्रोजेक्ट है, 100% फंडेड बाय इसरो। सो ये बहुत हमारा लिए खुशी की बात है कि हम इंडिया से ऐसा कुछ मिशन कर सकता है। तो ये दिखाने के लिए, सारा विश्व को दिखाने के लिए भी हमारे लिए काफी चैलेंजिंग है। एंड आपने जैसे बताया कि इंडिया का बहुत सारे इंस्टीट्यूट अपार्ट फ्रॉम इसरो के बगैर भी इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स, आयुका जो पुणे में है, TIFR फिजिकल रिसर्च लेबोरेटरी जो अहमदाबाद में है, देयर सेवरल आइजर पुणे, आइजर कोलकाता, IIT BHU, मैं अभी एरीज में हूँ, एरीज, और बहुत सारे इसरो का जो सेंटर्स है
यहाँ पे इंस्ट्रूमेंट बन रहा है। सो 7 इंस्ट्रूमेंट है, मैंने थोड़ा बताया पहले भी, ये कॉम्बिनेशन है 4 इंस्ट्रूमेंट सन की तरह की, इसको रिमोट सेंसिंग बोलते हैं, उसके साथ सन की तरह हमेशा देखने वाले हैं। एक एडवांटेज ये लैग्रेंजियन पॉइंट जाने का है कि ये 24/7 365 डेज सन को देख पाएंगे। ये जो छोटा ऑर्बिट होता है 500-600 किलोमीटर का सन सिंक्रोनस जो ऑर्बिट होता है, उसमें थोड़ा बहुत कुछ दिन के लिए एक्लिप्स वगैरह भी आ जाता है, हमेशा वो सन की तरफ देख नहीं सकता है। तो इसीलिए लैग्रेंजियन पॉइंट जाना एक साइंटिफिकली एडवांटेजेस है। और उसमें मैंने जैसा बोल रहे थे, इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स एक इंस्ट्रूमेंट बना रहा है, उसका नाम है कोरोनाग्राफ। हाँ, कोरोनाग्राफ एक्चुअली आर्टिफिशियली सोलर डिस्क को ब्लॉक करके कोरोना को स्टडी कर सकता है। सो टोटल सोलर एक्लिप्स का बोल सकते हैं कि एक उसी कंडीशन क्रिएट करना है। उसमें हम लोग 4 कैमरा है, एक एक कैमरा से आप एक एक चीज देख सकते हैं, आप सोच सकते हैं। तो वो कैमरा में से हम लोग स्पेक्ट्रोस्कोपी करेंगे और इमेजिंग भी करेंगे। मैं जैसा बोल रहा था कि इमेज के साथ आपका वो जो डायनामिकल चेंजेस जो होता है, जो परिवर्तन आता है, वो सबको कैप्चर करते हैं। बट उसका जो फिजिक्स है, उसका जो डेंसिटी कितना है, वेलोसिटी कितना है, टेम्परेचर कितना है, ये सब जानने के लिए ये स्पेक्ट्रोस्कोपी का जरूरी होता है। और वो स्पेक्ट्रोस्कोपी के साथ हमने स्पेक्ट्रोपोलरीमेट्री भी ऐड किया है। तो उसके हिसाब से हम पहली बार स्पेस से सोलर कोरोनल मैग्नेटिक फील्ड मेजर करने की कोशिश कर रहे हैं। ये अभी भी कोई भी देश किया नहीं है। आप बोल रहे थे कि और भी एक्चुअली 2 बड़ा वाला मिशन, एक ईजा का है जिसको बोलते हैं सोलर ऑर्बिटर, और एक नासा के मिशन है पार्कर सोलर प्रोब, जो 2-3 साल के बीच में अभी लॉन्च हुआ है। उसका जो साइंटिफिक ऑब्जेक्टिव्स है, वो जो कर रहा है, हम उसको कॉपी नहीं कर रहा है, हम दूसरी तरह का इंस्ट्रूमेंट बना रहे हैं जो कि कोई नया इंफॉर्मेशन दे। अभी साइंस ऐसा हो गया कि अभी आपका विश्व का डिफरेंट जगह में डिफरेंट ऑब्जर्वेटरी से जो नॉलेज आ रहा है, इसको इकट्ठा करना एक्चुअली एक इम्पॉर्टेंट एस्पेक्ट हो गया है। तो इसको बोलता है कोलैबोरेशन मोड में साइंस करो। तो साइंस इज नॉट ड्रिवन बाय बाउंड्रीज। तो आप हमारा मिशन से आप कुछ जानकारी करेंगे, ईजा का यूरोपियन स्पेस एजेंसी का मिशन से कुछ जानकारी करेंगे, नासा का मिशन से कुछ जानकारी करेंगे। ये सब इंफॉर्मेशन आप जब इकट्ठा करेंगे, उसी में आपका ये जो हम लोग को अनसॉल्व प्रॉब्लम्स है, उसको हम पूरा समझ में पाएंगे। तो इसीलिए ये बहुत ही एक महत्वपूर्ण बात है कि कोलैबोरेशन के साथ हम लोग साइंस आगे बढ़े। बट ये भी एक इम्पोर्टेंट है कि हमारा इंडिया से भी हम लोग को आगे जाने के लिए हमको भी कुछ बनाना चाहिए। तो ये कुछ बहुत ही प्राइड की बात है कि हम लोग अपना लैब में ये सब बना रहे हैं, वेरी सोफिस्टिकेटेड, वेरी चैलेंजिंग इंस्ट्रूमेंट, जो पहले किसी ने भी बनाया नहीं है। ये भी एक महत्वपूर्ण बात है।
सर, इस बात से बड़ी मुझे वो वाली याद आ रही है कि हमारे फादर ऑफ स्पेस प्रोग्राम डॉक्टर विक्रम साराभाई जिस मोटिव को लेके हमेशा आगे चला करते थे कि हम जियांट लीप की बात अगर करें तो हमें फ्रॉगिंग करना चाहिए। मतलब हम कॉम्पीट नहीं कर सकते हैं, तो लेकिन हम न्यू कॉन्सेप्ट, न्यू आइडियाज के साथ वर्ल्ड कॉन्ट्रीब्यूशन में, फ्रंटियर्स ऑफ साइंस में अपना योगदान दे सकते हैं। और ये बहुत अच्छा लगा कि हमारा आदित्य L1 सन को एक समझने के लिए उसमें कुछ ऐसे वैज्ञानिक पहलुओं को लेके आप चल रहे हैं जो दुनिया में बड़ा यूनिक है और जिसमें भारत को कंट्रीब्यूशन देखने मिलेगा आप सबके सहयोग से। हम कुछ सवाल इक्लिप्स के बारे में लेंगे क्योंकि ये टॉक इक्लिप्स से भी है। बीच बीच में मैं आपको पूछते हुए हमारी ऑडियंस के भी प्रश्न ले लेता हूँ। डिकोडिंग के एक कोई यूट्यूबर हैं, वो पूछ रहे हैं हाउ हेली एंड अदर एस्ट्रोनॉमर्स वर एबल टू प्रेडिक्ट द करेक्ट टाइमिंग एंड डेट ऑफ द इक्लिप्सेस वे बैक ड्यूरिंग देयर टाइम, हाउ दे वर एबल टू नो द करेक्ट इंफॉर्मेशन अबाउट द ऑर्बिट्स।
So what is important is you have to take continuous observation. So continuous observation से ही आपको पता चलता है कि ये जो planetary orbit का जो है आपका सनराइज सनसेट आप देख रहे हैं, उसमें जो अपरेंट जो साइज आप मेजर कर रहे हैं, ये कंटिन्यूअसली आप लेंगे तो उसी के साथ आप ये इकट्ठा, उस टाइम में तो कंप्यूटर नहीं था, तो आपको कैलकुलेशन ऑफ कोर्स केपलर्स मोशन ऑलरेडी जानकारी हो गया था, सो केपलर्स लॉज ऑफ मोशन से आपको पता था कि कैसा इलिप्टिकल ऑर्बिट होना है, हाँ, वो रेडियस और ये का टाइम पीरियड का क्या संबंध है, तो थोड़ा बहुत मैथमेटिकल जो फिजिक्स का ऑलरेडी जानकारी था उसी के हिसाब से, एंड जब डेली आप ऑब्जर्वेशन ले रहे हैं उसी के साथ आप मिला के इसको कर सकता है। बट वही इंपॉर्टेंट होता है कि आपका जो मेजरमेंट आप ले रहा है उसका प्रिसिशन क्या है, आप किसके साथ, ऐसा ही होता है ना कि आपका स्केल से आप कोई डिस्टेंस भी नापे तो वो स्केल का जो स्मॉलर डिवीजन है उसके ऊपर डिपेंड करता है कि आप कौन सा प्रिसिशन मेजर कर सकते हैं। आपका सेंटीमीटर स्मॉलर स्केल है या उससे नीचे भी स्केल है, तो इसके ऊपर सो यही है कि तब तक ऑलरेडी टाइम का भी काफी सारा ऑलरेडी एडवांसमेंट हो चुका था। आई थिंक हमारा क्लॉक्स बनने लग गए थे जो प्रिसिशन टाइमिंग ले सकता है, और साइज मेजरमेंट्स वर आल्सो प्रीटी गुड। सो ऑफ कोर्स दिस वाज मोस्टली इन द यूरोप, एंड उसके हिसाब से वो लोग इतने अच्छा से प्रेडिक्ट कर पाए थे।
ओके सर, जैसे कि आपकी टॉक की शुरुआत में भी और मिस्टर कृष्णेंदु ने भी ये बात छेड़ी थी राहु केतु की, तो एक ऑडियंस में से चित्रा जी हैं, वो पूछ रही हैं कि इन 1750 Kepler detailed information about eclipses. It means that they were ahead of us in knowledge. Ours were myth. Rahu, Ketu. Your frank opinion. So this is a very kind of contradiction. We always believe that Western world is very, very ahead of us. But somewhere down the line, because of the technological instrument advancement at their end, कुछ चीजें वो पहले देख पाए, लेकिन हम उनसे कॉन्ट्रडिक्शन में हमेशा फंस जाते हैं। तो आपका क्या योगदान है सर इस बारे में, मतलब आप क्या कहना चाहेंगे?
हाँ, देखिए एस्ट्रोनॉमी में इंडिया में भी काफी ऑब्जर्वेशन पहले से ही चल रहा था। Of course, later on Aryabhatta and all that also made a lot of contribution in terms of mathematical calculations and all. But ये बात सही है कि ये गैलीलियो से चालू हुआ, क्योंकि टेलीस्कोप यूज करना एस्ट्रोनॉमिकल ऑब्जर्वेशन के लिए यूरोप में काफी पूरा रेस्ट ऑफ द वर्ल्ड से काफी आगे थे, राइट? नो अदर प्लेस इन द वर्ल्ड। चाइना में भी ऑब्जर्वेशन होता था, बट चाइना में भी जो रिकॉर्ड करते थे, बट पूरा फिजिक्स वाइज जो डेवलपमेंट था, मेरे ख्याल से, मेरा जितना जानकारी है उतना एक्यूरेट नहीं थे। तो ये जो साइंटिफिक माइंड होता है, आई थिंक यूरोपियंस वर स्लाइटली अहेड ऑफ अस इन अ मोर ऑफ ए जनरल वे। आई वोंट, बट ऑफ कोर्स वी हैड famous scientists in those centuries as well, but common people were slightly more dictated by mythology to some extent. But I tell you मैंने जैसा बोलने का कोशिश किया, जब आपको ठीक से जानकारी नहीं होगा तभी आप डरेंगे, और आपको डर आएगा तो आप उसको तरह से आप एक्सप्लेन करने का कोशिश करेंगे, उसमें थोड़ा बहुत अनसाइंटिफिक थीम भी आ जाता है जब जानकारी। बट यही इंपॉर्टेंट होता है कि आपको जब जानकारी आ गया है तब आप सुपरस्टिशन को छोड़िए, राइट? जब तक आप जानते नहीं थे उसको तो हम बोल सकते हैं ठीक है हमको जानकारी नहीं था, बट अभी इस जमाना में हम जब जानते हैं कि ये इक्लिप्स एक सेलेस्टियल इवेंट है, उसमें हमका कोई क्षति नहीं हो सकता है, आपको डरने का क्या है? ये नहीं होना चाहिए। तो मेरे ख्याल से ये बहुत ही महत्वपूर्ण है आज के जमाने में कि लोग को समझाया जाए कि ये देखिए ये इसके लिए ऐसा हो रहा है, आपको डरने का कोई बात नहीं है, सुपरस्टिशन का कोई चारा ही नहीं है।
ठीक, तो सर कोई किसना गुप्ता जी हैं, दे आर आस्किंग, ही इज आस्किंग कि व्हाट इज हाइब्रिड इक्लिप्सेस।
हाँ, वो एक्चुअली वो एक्सप्लेन किया है थोड़ा बहुत वो मूवी में। मैं बोलता हूँ हाइब्रिड इक्लिप्सेस आर कि वर्ल्ड का कुछ लोकेशन में आपको जो रिलेटिव जो साइज में बोल रहा था कि डिस्टेंस और साइज का जो प्रोपोर्शन है वो ऐसा होना चाहिए। टोटल सोलर इक्लिप्स तब हो सकता है कि मून का साइज एग्जैक्टली एटलीस्ट डिस्क को ब्लॉक करे, नहीं तो थोड़ा ज्यादा भी हो सकता है मून का साइज, सो दैट इट इज परफेक्टली ब्लॉकिंग द सोलर डिस्क। और एनुलर इक्लिप्स जब होता है तब आपका जो मून का साइज वो सोलर डिस्क के साइज से थोड़ा छोटा है। बट ऐसा भी हो सकता है जहां पे एक इक्लिप्स में कहीं जगह में वर्ल्ड में आपको टोटलिटी देखे, बाकी जगह में आप एनुलरिटी देखे, तो उसी को हाइब्रिड कहे जाते हैं।
थैंक यू सर। बहुत 2-3 प्रश्न हम और लेंगे, पर मैं भी आउट ऑफ क्यूरियोसिटी हमारी ऑडियंस के लिए आप बताना चाहेंगे क्या? सर आर्थर एडिंगटन ने आइंस्टाइन के कॉन्सेप्ट को जाकर आपकी जैसे एक एक्सपीडिशंस में, मान लीजिए जहां से टोटल सोलर इक्लिप्स देखा जाता है, जाके एक थ्योरी को जो एक सॉलिड एविडेंस प्रोवाइड कराया, वो क्या था हमारी पूरी ऑडियंस के लिए अगर आप बताएं तो सर।
हाँ, तो क्या होता है कि जो थ्योरी में बताया गया था इंस्टेंट का, जो लाइट, इलेक्ट्रोमैग्नेटिक लाइट जो आता है डिस्टेंट ऑब्जेक्ट से, वो बेंड हो सकता है। उसको बेंड कभी हो सकता है जब एक सेलेस्टियल बॉडी उसका प्रेजेंस में रहेगा, तो लाइट बीम विल बी डिफ्लेक्टेड। तो ये एक्सपेरिमेंट करने के लिए टोटल सोलर इक्लिप्स को यूज किया गया था 1905 में। उस टाइम में बिफोर द इक्लिप्सेस, द स्टेलर पोजीशंस वर रिकॉर्डेड, एंड देन इक्लिप्स के टाइम में भी वो पोजीशन रिकॉर्ड किया था। इक्लिप्स के टाइम में कौन कौन स्टार कहाँ पे है, बिकॉज सन का पोजीशन तो हट गया है। तो उसको देख पता चला कि ड्यूरिंग द टोटलिटी जो पोजीशन आपको पीछे होना चाहिए वो दूसरी जगह देख रहा है। उसके मतलब कि लाइट बेंड कर गया था बिकॉज ऑफ द प्रेजेंस ऑफ द सन। सो द स्टार्स व्हिच आर बिहाइंड द सन, that light gets bent because of the presence of the celestial body, and कितना bend होगा ये सब calculation is depends on the mass and so on. So वही experiment करके confirmation हुआ था कि light will be bending because of the presence of the large amount of gravitating body.
तो मतलब ये बात साफ जाहिर है कि हम जितना एडवांस हो रहे हैं सोलर फिजिक्स की फील्ड में, और या हमारे एस्ट्रोनॉमिकल एडवांसमेंट ऑफ इंस्ट्रूमेंट्स की बदौलत, तो हम जितना ये ब्यूटीफुल सेलेस्टियल इवेंट्स हैं, उसके साथ साथ बहुत बड़ी अपॉर्चुनिटीज होती हैं विज्ञान के लिए कि हम इनमें कई एक्सपेरिमेंट्स विदाउट गोइंग इन आउटर स्पेस, हम बहुत कम खर्चे से डिजाइन करके वो टेस्ट कर सकते हैं।
Exactly.
तो एक बात आप जिक्र कर रहे थे आपके प्रेजेंटेशन में टेम्परेचर मेजरमेंट के बारे में कोरोना का, तो मेरे जहन में एक प्रश्न आ रहा था कि सोलर अकल्टेशन, हम जब आर्टिफिशियली अकल्टेशन डिस्क यूज करते हैं, उसको लगाने के बाद जो कोरोनल टेम्परेचर चेंज होता है और टोटल सोलर इक्लिप्स के समय जो कोरोनल टेम्परेचर चेंज होता है, उन दोनों में लगभग कितनी सिमिलैरिटीज होती हैं या बहुत डिफरेंट है दोनों?
नहीं, कोई चेंज नहीं होता है, बिकॉज ऐसी बात आपका सोच पहले ही समझने चाहिए। सन हमारे से देख लीजिए 100 यूनिट में बहुत दूर है, और जो हमने L1 पॉइंट जा रहा है वो एक्चुअली 1% डिस्टेंस जा रहे हैं।
ओके,
हाँ, तो हमारा अर्थ बहुत ही पास में है। तो सन का एटमॉस्फेयर में कोरोना में कोई भी चेंज नहीं होने वाला है, बिकॉज सन का पता भी नहीं है कि आपके सामने मून आ गया है। तो ये लैग्रेंजियन 1 पॉइंट पे हम जो सैटेलाइट पे लेके जा रहे हैं, वो सन को पता नहीं है कि सामने आ गया है। तो सोलर जो कोरोनल टेम्परेचर है वो कभी भी चेंज नहीं हो सकता है।
मतलब ड्रॉप भी नहीं होगा सर? थोड़ा बहुत
नहीं, वो चेंज आपको जो दिखता है वो अर्थ में होगा, बिकॉज सडनली आपको रात के जैसा थोड़ा देर के लिए रात जैसा हो गया होगा, तो बिकॉज सन का जो रोशनी आता है उसके लिए तो ग्राउंड टेम्परेचर ज्यादा होता है, तो रोशनी कम हो जाएगा, रात का टेम्परेचर तो आपको नीचे होता है, तो रात जैसा ये होगा, तो अर्थ का एटमोसफियर बदल सकता है, थोड़ा बहुत बदलता है भाई, डिपेंड करता है कि कैसा कंडीशन है, बहुत ही गर्म है या विंटर में है, उसमें फर्क होता है। बट कोरोनल टेम्परेचर कैनॉट चेंज because of the eclipses. Coronal temperature changes because of the changes in the sun. सन का एटमॉस्फेयर में मैग्नेटिक फील्ड है, बहुत सारे डायनामिकल चेंजेस रहता है, तो उसके वजह से सन का टेम्परेचर चेंज होता है। और अभी इस साल सन का जो कोरोना में टेम्परेचर कहीं कहीं जगह पे वो जो मैग्नेटिक स्ट्रक्चर होगा उसके हिसाब से जैसा होगा, आगे 3 साल बाद एक्चुअली सन का मैंने वो बात बताई भी नहीं है। सोलर साइकिल एक बात होता है, जो सनस्पॉट जो मैग्नेटिक फील्ड का जो मेजरमेंट होता है वो कभी बहुत सारे सनस्पॉट दिखता है, समटाइम्स कोई सनस्पॉट दिखता भी नहीं है, तो इसका एक फर्क होता है, उसी टाइम में टेम्परेचर का फर्क होता है। कोरोना में
अभी लगभग 2 या 3 सनस्पॉट्स हैं एट प्रेजेंट ड्यूरिंग दिस फेज। सो एक प्रश्न हम ले लेते हैं ऑडियंस से सर। चित्रा जी पूछ रही हैं कि हम टेम्परेचर कैसे मेजर करते हैं? हमारे सन का 5000 डिग्री बोलते हैं, तो स्पाइक एक स्टार है उसका 22127 डिग्री है, तो आप इसको बता सकेंगे तो अच्छा रहेगा।
तो ये एक्चुअली स्पेक्ट्रोस्कोपी से करते हैं। So spectral line of different ions are formed because of the presence of certain temperature. आप समझ लीजिए आयरन लो आयनाइजेशन स्टेट का जो आयरन लाइंस होगा वो उसका that temperature will represent tens of thousands of Kelvin. हाँ, यही हमने टेम्परेचर ज्यादा इंक्रीज करेंगे तो ये आपका आयरन
15 आयरन 20 आयरन 25 लाइन्स हो सकता है. इसका मतलब है these are different ionization state of the element iron. So in the solar atmosphere there are different elements available. There are carbon, there is oxygen. So all these different elements are in different ionization state because of the temperature.
Okay. Okay, sir. Hello. Hello.
लोग मेजर करेंगे तो वो स्पेक्ट्रल लाइन का प्रॉपर्टी 2-3 स्पेक्ट्रल लाइन को कंपेयर करके हम टेम्परेचर.
सर आपकी आवाज जा रही है स्वप्निल.
हमारा एटॉमिक फिजिक्स जो लैबोरेटरी एक्सपेरिमेंट है उससे जानकारी है. तो ऑफ कोर्स हमको वो भी बहुत इंपॉर्टेंट है कि लैबोरेटरी में आप एक्सपेरिमेंट करो, आप कंप्यूटर में एक्सपेरिमेंट करो, करके पता करो ये ट्रांजिशन.
I think because we lost because of internet connectivity थोड़ा सा. Thank you. We should now wrap up. जाते जाते सर क्विकली अगर आपके पास 1 मिनट है तो थोड़ा सा हमारे स्कूल्स के ऑडियंस के लिए और पब्लिक के लिए बता जाएं अपकमिंग नेशनल लार्ज सोलर टेलीस्कोप के बारे में, जो जिसके आप प्रोजेक्ट कोऑर्डिनेटर भी हैं, प्रोजेक्ट इंचार्ज भी हैं जिस प्रोजेक्ट के आप सर.
हाँ, तो ये नेशनल लार्ज सोलर टेलीस्कोप ये एक ग्राउंड बेस्ड टेलीस्कोप है. एंड ये इसका जो भी टेलीस्कोप का जो प्राइमरी बेंडर होता है वो जितना बड़ा होगा उसके साथ आप जो दूर का जो ऑब्जेक्ट देखना चाहते हैं उसको आप उसके डिटेल्स और ज्यादा देख पाएंगे. हाँ, तो सन इज ए नियरेस्ट स्टार, तो आप ज्यादा बड़ा करेंगे तो एक्चुअली लाइट बहुत ज्यादा होगा. वो एक दूसरा चैलेंज है. वो अपना इतना बड़ा हीट जो कलेक्ट करेंगे उसको कैसे आप संभाल पाएंगे, वो सब तो है. बट आपका बड़ा वाला टेलीस्कोप होगा तो सन का जो सरफेस में जो जितना डिटेल्स है, जो साइज हमने सनस्पॉट का देखिए 5000 किलोमीटर बोल रहे हैं, उसका कितना छोटा छोटा पोर्शन हम देख पाएंगे वो डिपेंड करता है. तो ये 2 मीटर वाला टेलीस्कोप हम लोग हिमालय में लद्दाख एक एरिया में हमारा ऑलरेडी इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स का ऑब्जर्वेटरी है. वहाँ पे उसका आसपास में और एक जगह में हम लोग बनाने का डिसाइड किया हुआ है. एंड उसमें भी काफी सारे इमेज और ये स्पेक्ट्रोस्कोपी जो फैसिलिटी हम बोल रहे थे उसका कंबाइन करेंगे. ये भी आइडिया है. देखिए इंडिया में अभी एक इतना बड़ा ग्राउंड बेस्ड टेलीस्कोप हो गया और एक स्पेस में स्पेस बेस्ड आदित्य L1 हो गया, तो ये दोनों मिला के तो हम बहुत कुछ कर सकते हैं. एंड ये बच्चे के अभी जो छोटा बच्चे हैं वो जब बड़े होंगे उनके लिए एक बहुत ही बड़ा फैसिलिटी हो जाएंगे. और हम चाहते हैं कि ये सब बच्चे सोलर फिजिक्स में आए, एस्ट्रोफिजिक्स में आए और इसको आगे ले जाए.
थैंक यू सो मच सर, आपने अपने बिजी शेड्यूल में से इतने शॉर्ट नोटिस पे हमें समय दिया. और खास बात है कि यू आर नोन फॉर ग्लोबली कि आप आउटरीच में भी अपना कंट्रीब्यूशन बरकरार रखते हैं, चाहे कितनी भी व्यस्त हो, कितने भी डिफिकल्ट टाइम्स हो. और ये आने वाले समय में भारत के लिए सोलर फिजिक्स का एक बहुत अच्छी फैसिलिटीज रहेंगी अपकमिंग जनरेशंस के लिए. तो थैंक यू सो मच ऑन बिहाफ ऑफ रीजनल साइंस सेंटर की. आपसे हम फ्यूचर में भी जुड़ेंगे सर, और भी बड़ी इवेंट्स करेंगे, इंटरेक्टिव प्रोग्राम्स करेंगे आपके इंस्टीट्यूट के साथ मिलके. हम चाहेंगे कि हमारी जो सुनने वाले बच्चे हैं अगर इनके मन में कोई भी सवाल या प्रश्न है तो वो हमें विज्ञान केंद्र भोपाल पे भेजें. हम एरीज के थ्रू आपको जवाब जरूर पहुंचाने का कष्ट करेंगे. और सर आपको बहुत बहुत धन्यवाद हमारे इस विज्ञान की तरफ से, विज्ञान केंद्र की तरफ से, हमारी काउंसिल की तरफ से कि आपने बेहतर तरीके से प्रेजेंट किया. और लास्ट में आपने जो Q&A सेशन इंटरेक्टिवली प्रेजेंट किया, दैट्स अ फिनोमिनल. थैंक यू सो मच सर.
थैंक यू. इट्स माय प्लेजर. इट्स माय प्लेजर.
थैंक यू.
Okay, so I will probably have stopped